the thermal flow measurement principle is very common for HVAC, heating, ventilation, and air condition. And the idea is that you have a PT100 element at the thermal sensor, which measures the temperature of the fluid, usually the gas. And then you have another temperature sensor, but that one is heated by a current. If you have a constant current, you would expect a constant temperature difference between the two. But if you have a flow, you will have more cooling effect on that one, and therefore the temperature difference goes down. So the temperature difference between the normal PT100 and the heated PT100, the temperature difference between the two depends on the flow. Alternatively, you can say that you want 10 degrees difference between the two, how much current is required to achieve that temperature difference of 10 degrees, for example. And the flow rate is what determines the cooling effect of the heated probe. As I said, it's very common in ventilation systems. You have to be careful to where you place the sensor. Usually the sensor is with two PT100s embedded in the same rod, and the rod should be installed so that the active area is in the middle of the flow. It's very popular for ventilation systems because it works very well with, for example, square ducts, where the pipes not necessarily are round, but where the ventilation ducts are squared. So it works very well for such applications. And it can be installed horizontally, vertically, whatever. So that's why it's quite popular for such applications.